Hello and welcome to Sleepy Lab. I'm so glad you found your way here tonight. Maybe you've had a long day, or maybe you simply enjoy drifting off to the sound of quiet wonders and gentle truths. Either way, there's nothing you need to do right now. No tasks to finish, no decisions to make. Just rest. Let your shoulders drop. Let your breathing slow. Let your mind soften like twilight settling over a distant hill. Tonight, we're going to explore something you've seen 1,000 times but perhaps never truly noticed. Moonlight, the pale glow that finds its way through your window on clear nights. The silver thread that stitches together dusk and dawn. We'll wander through the science of how moonlight changes, why it looks the way it does, and what happens in the natural world when the moon rises and the sun fades. There are no quizzes, no facts to memorize. Only soft observations drifting like clouds across a quiet sky. And before we begin, if these calm explorations help you unwind, or if they give you a peaceful way to end your day, consider liking this video and subscribing to the channel. It helps others find their way here too, one sleepy soul at a time. Now, let's begin. Moonlight is not its own light. It's borrowed, reflected. The moon does not burn or shine from within. It has no fusion, no fire, no core of energy waiting to burst outward. Instead, it catches the light of the sun and gently sends it back toward us, softened and transformed. What we call moonlight is really sunlight that has traveled across space, struck the surface of the moon, and bounced back through the dark to reach Earth. It is second-hand starlight, quiet, patient, always arriving late, like an echo. The moon reflects only about 12% of the sunlight that touches it. Most of the light is absorbed by its dusty, ancient surface. 12% doesn't sound like much, and it isn't. But on a clear night, far from the glow of cities, that small fraction is enough to cast shadows, enough to light a path, enough to turn the landscape into something soft and strange, neither day nor night, but a third kind of time altogether. This borrowed light has traveled nearly 240,000 miles from the moon to your eyes. It moves at the speed of light, so it takes just over a second to make the journey. But before that, it traveled 93 million miles from the sun to the moon, taking about 8 minutes. By the time you see moonlight, it has crossed vast distances, reflected off ancient stone, and arrived at your window carrying with it the memory of two worlds, one burning, one silent. Moonlight is always changing. The moon does not give the same light every night. Sometimes it's a thin crescent, barely visible in the evening sky. Other times it's full and round, flooding the world with pale silver. These changes are not random. They follow a rhythm, a cycle that takes about 29.5 days to complete. This is called a lunar month, and it governs the phases of the moon, the tides of the ocean, and the moods of the night itself. The phases occur because the moon orbits Earth, and as it moves, the angle between the sun, the moon, and Earth changes. When the moon is between Earth and the sun, we see the side that is in shadow. This is the new moon, and there is almost no moonlight. When Earth is between the sun and the moon, we see the side that is fully lit. This is the full moon, and the night is brightest. In between, the moon waxes and wanes, growing fuller and shrinking again, like a slow breath in and out. The light of a full moon is about 400,000 times dimmer than direct sunlight. It seems bright to us at night because our eyes adjust, our pupils widen, and our vision shifts into a different mode. But if you were to compare the two side by side, moonlight would barely register. It is a whisper compared to the sun's shout. And yet, in the context of night, it is enough. Enough to read by if the print is large. Enough to walk by if the path is clear. Enough to transform darkness into something softer. Human cultures have always noticed this rhythm. They tracked the phases of the moon long before they understood what caused them. The lunar cycle became a way to measure time, to mark the passage of weeks and months. Ancient calendars were built around it. Festivals were timed to it. The word month itself comes from moon. For thousands of years, people lived by moonlight. They planted crops by it. They traveled by it. They told stories under it, passing down myths and memories beneath its changing face. Even now, in a world lit by electric bulbs and glowing screens, the moon still pulls at something deep inside us. We look up at it and feel a kind of recognition, not because we understand it fully, but because it has always been there, turning slowly above us, marking time in a language older than words. Moonlight looks different depending on where the moon is in the sky. When the moon is low on the horizon, just after it rises or just before it sets, its light passes through more of Earth's atmosphere. The atmosphere scatters the shorter wavelengths of light, the blues and violets, and lets the longer wavelengths, the reds and oranges, pass through. This is why the moon often looks warmer and more golden near the horizon. It's the same effect that makes sunsets red. The light has to travel a longer path through the air, and along the way, it changes. When the moon is high overhead, its light passes through less atmosphere. It appears whiter, colder, more pure. The difference is subtle, but if you pay attention, you can see it. The moonlight that filters through your window at midnight feels different from the moonlight that slips over the hills at dusk. One is clear and sharp. The other is soft and hazy, like a memory of daylight. The color of moonlight also depends on the moon's surface. The moon is covered in regolith, a layer of fine dust and broken rock created by billions of years of meteor impacts. This material is dark grey, almost charcoal in tone. It absorbs most colors of light equally, which is why the moon reflects a relatively neutral spectrum. But there are subtle variations. Some areas of the moon are slightly richer in iron and appear darker. These are the Maria, the ancient lava plains that form the shadowy features we see from Earth. Other areas are brighter, made of lighter rock from the moon's highlands. These differences create the patterns we recognize, the face we think we see looking back at us. Moonlight is polarized. When sunlight reflects off the moon, it doesn't just change in brightness or color. It also becomes partially polarized, meaning the light waves align in certain directions rather than vibrating randomly. This polarization is subtle, invisible to the human eye, but some animals can detect it. Certain insects, birds, and marine creatures use polarized light to navigate, to orient themselves in space, to find their way home. To them, moonlight is not just a glow, it's a map. The degree of polarization changes depending on the angle of the light. When the moon is full and we see it head-on, the polarization is weakest. When the moon is a crescent and we see it at an angle, the polarization strengthens. This shift happens gradually, night by night, as the moon moves through its phases. The light is never quite the same twice. It bends, it turns, it shifts in ways we don't consciously perceive, but which shape the experience of night nonetheless. There is something calming in this constancy of change. The moon does not stay the same, but its changes are predictable. You can look up tonight and know roughly what the moon will look like next week, next month, next year. It is a kind of order in the chaos, a rhythm you can count on, even when so much else feels uncertain. Moonlight affects how we see color. Human vision relies on two types of light-sensitive cells in the eye, rods and cones. Cones are responsible for color vision and work best in bright light. Rods are more sensitive and allow us to see in dim conditions, but they don't detect color well. Under moonlight, our cones struggle. There isn't enough light for them to function properly. Instead, our rods take over, and the world shifts into shades of grey, blue, and silver. This is why moonlit landscapes often feel drained of color. The grass is not green, the flowers are not red or yellow. Everything is muted, softened, translated into a narrow band of tones. Scientists call this scotopic vision, the kind of seeing that happens in low light. It's not black and white, exactly. There are still subtle hues, faint suggestions of warmth or coolness. But the vividness of daylight is gone. The world becomes quieter visually, less demanding, easier to rest in. Some people find this unsettling. The loss of color can make familiar places feel strange, almost otherworldly. But others find it peaceful. When the world is less bright, less defined, it asks less of you. You don't have to take it all in. You can let your eyes relax. Let your focus soften and simply exist within the dim glow without needing to see everything clearly. Artists have always been fascinated by this quality of moonlight. Painters from centuries past tried to capture it, the way it flattens depth, blurs edges, and turns solid objects into shapes and suggestions. Photographers, too, have chased the challenge of moonlit scenes, knowing that the camera sees differently than the eye, and that what looks magical in person can appear flat or dark on film. There is a kind of translation required, an understanding that moonlight is not just dimmer sunlight, it's a different kind of seeing altogether. The brightness of moonlight varies more than you might think. A full moon on a clear night can provide as much as 25 lux of illumination. That's enough to cast distinct shadows, to read large print, to see your breath in the cold air. But when the moon is a thin crescent, or when clouds cover the sky, the light can drop to nearly nothing. The difference between a moonlit night and a moonless night is profound. One feels open, navigable, almost generous. The other feels closed, inward, like the world has drawn a curtain. This variation affects not just how we see, but how we feel. Studies have shown that people sleep differently depending on the phase of the moon. Some report lighter sleep during a full moon, even when they're indoors and can't see it. Others feel more restless, more wakeful, as if some ancient part of the brain is still tuned to the rhythms of light and dark that governed our ancestors. The effect is subtle, not universal, and scientists are still debating how much of it is real and how much is expectation. But the pattern persists across cultures and centuries. The full moon has a reputation, deserved or not, for stirring things up. Moonlight has been measured, quantified, and studied, but it resists being fully explained. There is something about it that remains elusive. Perhaps it's because it exists in the liminal space between visibility and invisibility, between day and night, between the known and the unknown. It's light, but barely. It's enough, but only just. And in that narrow margin, in that thin band of illumination, something shifts. The world becomes softer. Time slows. The sharp edges of the day dissolve, and what remains is quieter, gentler, more forgiving. Tonight, as you listen, the moon may or may not be visible from where you are. It may be full or new, rising or setting, hidden behind clouds or shining clearly, but wherever it is, it's there, turning slowly in its orbit, catching light and sending back. Marking time in the oldest way we know. The moon's surface has been untouched by wind or rain for billions of years. When light from the sun strikes it, it's hitting a landscape frozen in time. There are no trees to sway in a breeze, no rivers to carve valleys, no clouds to scatter the light. Just stone and dust, craters and plains, silent and still. The light that reflects off this surface has touched something ancient, something that has not changed since long before humans existed. Then it travels to us, carrying with it that stillness, that silence, that sense of deep time. The moon has no atmosphere to soften or diffuse the light. On Earth, when sunlight enters the atmosphere, it's scattered by air molecules, creating the blue of the sky and the gradients of dawn and dusk. But the moon has none of that. On the lunar surface, the sun rises sharp and unfiltered, and when it sets, the transition to darkness is instant. There is no twilight on the moon, no gentle fading, just light and then shadow, with nothing in between. This means that the light reflecting off the moon has a kind of purity. It hasn't been filtered through layers of air or bent by atmospheric conditions. It's direct, unmediated, raw in a way that sunlight on Earth is not. Of course, by the time it reaches us, it has to pass through our atmosphere, and it gets scattered and softened just like any other light. But there's still something about it that feels different, cleaner, more remote. People have always wondered what moonlight is made of. Ancient Greeks thought it was a different substance than sunlight, something cooler, wetter, more feminine. They associated it with the goddess Artemis, with silver, with the tides and the subconscious. It wasn't until the 17th century that scientists began to understand that moonlight was simply reflected sunlight. Even then, the idea took time to settle. It felt counterintuitive. Sunlight is warm and golden. Moonlight is cold and pale. How could they be the same thing? The difference, of course, is not in the light itself, but in how we perceive it. Our eyes adapt to different levels of brightness. Our brains interpret the context, and the moon's surface, being dark and relatively unreflective, absorbs most of the warmth of the spectrum and sends back the cooler tones. The result is a light that feels fundamentally different, even though, photon by photon, it's the same light that warms our skin during the day. Moonlight moves at the same speed as all light, 299,792 kilometers per second. But because it has to travel from the sun to the moon and then from the moon to Earth, it takes a little longer to reach us than direct sunlight does. Not much longer, about a second and a quarter in total. But that delay is real. When you look at the moon, you're seeing it as it was just over a second ago. You're seeing light that has already completed one journey and is now completing a second. This double journey gives moonlight a kind of echo quality. It's light that has already been somewhere else. It has touched another world, been absorbed and re-emitted, and only then continued onward. In a sense, moonlight is older than sunlight, at least in terms of travel time. It has been through more, seen more, and perhaps that's part of why it feels so contemplative. It's light with a history. The brightness of the moon changes not just with its phase, but also with its distance from Earth. The moon's orbit is not a perfect circle, it's an ellipse, which means that sometimes the moon is closer to us and sometimes it's farther away. When it's closest, at a point called perigee, it's about 356,500 kilometers away. When it's farthest, at apogee, it's about 406,700 kilometers away. That's a difference of 50,000 kilometers, enough to make the moon look noticeably larger and brighter when it's near. A full moon that occurs at perigee is often called a supermoon. It can appear up to 14% larger and 30% brighter than a full moon at apogee. The difference is subtle if you're not paying attention, but if you compare photographs taken at different distances, it's clear. The moon swells and shrinks, grows brighter and dimmer, following a rhythm that overlaps with but is distinct from the rhythm of its phases. The two cycles, the cycle of phases and the cycle of distance, interact in complex ways, creating a tapestry of variation that repeats, but never exactly. Some months the full moon coincides with perigee and the night is flooded with light. Other months the full moon occurs at apogee and the glow is gentler, more restrained. Neither is better or worse. They're just different, like the difference between a loud whisper and a soft one. Both are still whispers. The moon's orbit is gradually changing. Every year the moon drifts about 8 centimeters farther from Earth. This happens because of tidal forces. The gravitational pull between Earth and the moon creates bulges in Earth's oceans, and as the planet rotates beneath these bulges, friction occurs. This friction transfers energy from Earth's rotation to the moon's orbit, causing the moon to slowly spiral outward. It's an incredibly slow process. You would never notice it in a human lifetime. But over millions of years, the effect is significant. Billions of years ago, the moon was much closer. The tides were higher, the days were shorter, and the moon appeared much larger in the sky. If you could go back in time and stand on a beach 4 billion years ago, you would see a moon that filled a much greater portion of the sky, looming and immense. The moonlight would have been brighter, the nights less dark, and the gravitational pull stronger. The Earth and moon were locked in a tighter dance, and the rhythm of light and tide was faster, more intense. Now the moon is drifting away. In another billion years or so, it will be farther still, smaller in the sky, dimmer at night. The total solar eclipses we experience now, where the moon perfectly covers the sun, will no longer be possible. The moon will be too small, too distant. It will pass in front of the sun and leave a ring of light around the edges. The precise alignment we enjoy is temporary, a coincidence of timing and distance that will not last forever. But for now, in this brief window of cosmic time, the moon is just the right size and just the right distance to create the nights we know. The moonlight we see is the moonlight of this particular era, this particular configuration of Earth and moon and sun. It has not always been this way, and it will not always be this way, but tonight it is. Moonlight interacts with Earth's atmosphere in delicate ways. When the moon is low on the horizon, its light has to pass through a thick layer of air, and the shorter wavelengths, the blues and violets, get scattered away. This is the same process that makes the sky blue during the day and the sunset red in the evening. By the time the moonlight reaches your eyes, it has been filtered, warmed, softened. It takes on hues of gold, amber, even orange, depending on how much dust or moisture is in the air. When the moon is high, the path through the atmosphere is shorter, and less scattering occurs. The light remains cooler, whiter, closer to its original color. On a perfectly clear night, with no humidity or haze, the high moon can look almost silver, a pale metallic glow that feels sharp and clean. But the atmosphere is rarely perfectly clear. There are always particles in the air, water droplets, dust, pollen, pollution. These particles scatter and diffuse the light, creating halos, glows, and soft gradients around the moon. Sometimes the moon seems to sit inside a cloud of light, a gentle aura that blurs its edges. Other times, especially in cold, dry air, the moon looks crisp and hard, its edge a sharp line against the black. The amount of moisture in the air affects how far moonlight can travel. In humid conditions, the air is thick with tiny droplets, and light gets scattered in all directions. This creates a kind of veil, a diffuse glow that spreads across the sky. You can see this effect on foggy nights, when the moon becomes a soft blur, a source of light without a clear shape. The light is there, but it's been broken apart, redistributed, turned into atmosphere itself. In dry, clear conditions, moonlight can travel farther and more directly. The air is transparent, almost invisible, and the moon's light reaches the ground with less interference. Shadows are sharper, contrasts are stronger, the world looks more defined, more etched. Deserts, high altitudes, polar regions in winter. These are places where moonlight takes on a particular clarity, a brightness that feels almost cold. The temperature of the air doesn't change the light itself, but it changes how the light feels. Moonlight on a warm summer night feels gentle, inviting, like something you could wrap around yourself. Moonlight on a cold winter night feels distant, remote, like it's reaching you from very far away. The physical properties of the light are the same, but the context shifts everything. This is one of the strange things about perception. Light is just electromagnetic radiation, photons traveling through space. But we don't experience it that way. We experience it as warmth or coldness, brightness or dimness, comfort or unease. The light itself is neutral, but we are not. We bring our bodies, our histories, our associations, and we fold them into everything we see. Moonlight has inspired countless myths, poems, paintings, and songs. It has been called the lamp of night, the wanderer, the silent witness. It has been associated with dreams, madness, longing, transformation. Werewolves, lunacy, romance under the moon. These are all stories we've told to make sense of something that is, at its core, just reflected sunlight. But stories matter. They shape how we see. And because humans have been telling stories about moonlight for thousands of years, those stories have become part of the light itself, at least in our minds. In many cultures, the moon is seen as a timekeeper. The lunar calendar, based on the cycles of the moon, was one of the first ways humans organized time. Months were measured from new moon to new moon. Festivals were timed to the full moon. The moon's phases were used to predict tides, to guide fishing and planting, to mark the passage of seasons. Even now, in a world dominated by solar calendars, the moon still governs certain traditions. Easter is calculated based on the lunar calendar. Ramadan follows the moon. The Chinese New Year is a lunar event. The moon's light was also practical. Before electric lighting, moonlight was the best source of illumination after sunset. People planned journeys around the full moon, knowing they would have enough light to travel safely. Harvest moons, the full moons closest to the autumn equinox, were especially valued because they rose early and provided light for farmers working late into the evening. The moon, in this sense, was not just poetic, it was useful. It extended the day. It made night navigable. There is a phenomenon called earthshine, and it happens when the Earth reflects sunlight back onto the moon. If you've ever looked at a crescent moon, notice that the dark part of the moon is faintly visible, glowing with a soft, ghostly light. That's earthshine. The light from the sun hits Earth, reflects off our clouds and oceans, travels to the moon, and then reflects back to us. It's light that has made 3 stops: sun to Earth, Earth to moon, moon back to Earth. It's sunlight that has touched home twice. Earthshine is most visible when the moon is a thin crescent, because that's when the Earth, as seen from the moon, is nearly full. Just as we see a full moon when the sun fully illuminates the side facing us, someone standing on the moon would see a full Earth, bright and blue, hanging in their sky. That bright Earth casts light onto the moon's surface, and some of that light bounces back to us. It's faint, much fainter than direct moonlight, but it's there, a whisper of a whisper. This double reflection gives Earthshine a unique quality. It carries the color of Earth, the blues of the oceans, the whites of the clouds, the greens and browns of the land. It's slightly warmer, slightly softer than regular moonlight. It's as if the moon is holding up a mirror, showing us a reflection of ourselves, filtered and transformed. The visibility of Earthshine depends on how reflective Earth is at that moment. If there are a lot of clouds over the side of Earth facing the moon, more light gets reflected, and Earthshine is brighter. If the skies are clear, less light bounces back and Earthshine dims. The brightness of Earthshine can vary from night to night, depending on weather patterns, ice cover, and even the season. In winter, when there's more snow and ice in the northern hemisphere, Earth is more reflective and Earthshine is stronger. It's strange to think that moonlight can be influenced by the weather on Earth, that the brightness of the moon's dark limb depends on whether it's cloudy in the Pacific or clear over the Atlantic. It ties the two bodies together in a way that feels intimate. The moon is not just reflecting the sun, it's reflecting us, our atmosphere, our weather, our changing surface. Every time you see Earthshine, you're seeing a piece of home, sent to the moon and returned. Moonlight has a rhythm, but it's not a simple one. The phases of the moon follow a 29, 5-day cycle, but the timing of moonrise and moonset shifts every day. The moon rises about 50 minutes later each night, on average, because of the way it orbits Earth. This means that sometimes the moon is up during the day and invisible against the bright sky, and other times it rises late at night, long after the sun has set. This shifting schedule creates a kind of unpredictability. You can't count on the moon being in the same place at the same time every night. Sometimes it greets you at dusk, hanging low and golden in the eastern sky. Other times it doesn't rise until midnight, or later. And for a few days each month, during the new moon, it's not visible at all, lost in the glare of the sun. This irregularity is part of what makes moonlight feel less reliable than sunlight. The sun rises and sets at predictable times. You can set your clock by it, but the moon drifts, wanders, appears and disappears according to its own rhythm. You have to pay attention to catch it. You have to look up at the right time. There's something calming in that unpredictability, though. It means the moon is not something you can take for granted. It's a gift when it appears, a presence when it's there, and an absence when it's not. It teaches a kind of patience, a willingness to wait and see what the night will bring. The angle of the moon's orbit also affects when and where it rises. The moon's path across the sky is tilted relative to the equator, and this tilt changes over an 6-year cycle. Sometimes the moon rises far to the north, and other times far to the south. This means that the moon's position in the sky and the direction of its light shifts gradually over years. It's a slow wobble, a long-term rhythm that overlays the monthly rhythm of phases. If you watch the moon carefully over many years, you'll notice these patterns. You'll see that some years the full moon climbs high in the winter sky, and other years it stays low. You'll see that the shadows it casts change angle, that the light enters your window from a slightly different direction. These are the long cycles, the deep rhythms that ancient astronomers tracked with stones and markers, trying to understand the motion of the heavens. Moonlight changes with the seasons, not because the moon itself changes, but because our relationship to it does. In summer, the full moon is lower in the sky and its light comes at a shallow angle. In winter, the full moon rises higher and its light is more direct. This is because the moon's orbit is tilted, and as Earth moves around the sun, our perspective shifts. A winter full moon can be startlingly bright, casting strong shadows across snow, while a summer full moon feels gentler, softer, more diffuse. The length of the night also affects how much time we spend in moonlight. In summer, nights are short, and even if the moon is full, it's only visible for a few hours. In winter, nights are long, and a full moon can be up for 12 hours or more, flooding the landscape with light from dusk until dawn. The experience of a moonlit night is shaped as much by the season as by the phase of the moon. There are places on Earth where moonlight takes on unusual qualities. In polar regions, during the long winter night, the moon can be up for days at a time, circling the horizon without setting. This creates a kind of perpetual twilight, a dim glow that never quite fades. The light is constant but weak, filtering through cold air and ice crystals, creating halos and pillars and strange optical effects. In tropical regions near the equator, the moon rises and sets almost vertically, moving straight up from the horizon straight down again. This makes the crescent moon look like a boat lying on its back, rather than tilted like a smile or frown. The orientation of the moon's crescent depends on your latitude, and it's one of those small details that travelers notice when they move between climates. The moon itself hasn't changed, but the angle of viewing has, and that's enough to make it look unfamiliar. At high altitudes, where the air is thin, moonlight is brighter and sharper. There's less atmosphere to scatter or absorb the light, and the stars and moon both appear more vivid. Mountaineers and astronomers seek out these high places for this reason. The light is clearer, the shadows more defined. The night feels closer, less filtered, as if you're seeing it the way it really is, without the softening veil of thick air. Cities, of course, have their own relationship with moonlight. In urban areas, artificial light is so bright that moonlight often goes unnoticed. The glow of street lights, buildings and screens washes out the subtlety of the moon's contribution. Even a full moon can seem dim compared to a well-lit street. Many people living in cities rarely see true moonlight, or if they do, they don't recognize it. The night sky is not dark enough for the moon to stand out, but even in cities, moonlight is there. It's just hidden beneath layers of other light. If you turn off the lamps, step away from the windows, and let your eyes adjust, you can still find it. It's still falling, still reflecting, still marking the passage of time. The moon doesn't care whether you notice. It continues its cycle regardless, drifting through phases, casting light onto streets and rooftops and rivers whether anyone is looking or not. There is something humbling in that. The moon has been doing this for billions of years. Long before cities, before humans, before life itself, the moon was orbiting Earth and reflecting light. It will continue long after we're gone. The light we see tonight is part of an ancient pattern, a rhythm that has persisted through ice ages and mass extinctions, through the rise and fall of species and civilizations. We are brief visitors to this cycle. The moon is a permanent resident. Moonlight has been studied scientifically, measured and quantified, but it resists being fully captured by numbers. Yes, we know its brightness in lux, its wavelength distribution, its polarization. We can predict when it will rise and set, when it will be full or new, how large it will appear. But knowing these things doesn't quite explain the experience of standing under a full moon on a quiet night and feeling something shift inside you. Some combination of awe, calm, smallness, connection. Perhaps it's because moonlight exists in a threshold. It's light, but barely. It's enough to see by, but not enough to see clearly. It creates a world that is half visible, half hidden, inviting the imagination to fill in the gaps. In full daylight, everything is clear. In total darkness, nothing is visible. But in moonlight, there's just enough to suggest shapes, to hint at forms, without revealing them completely. The mind has to participate. You have to meet the light halfway. This makes moonlight a collaborative experience. You don't just receive it passively. You interpret it, project onto it, wonder about it. The same landscape that looks ordinary in daylight can feel mysterious under the moon, not because it has changed, but because your way of seeing has changed. You're using a different part of your vision, a different part of your mind. Animals respond to moonlight in ways we're only beginning to understand. For many species, the moon is a crucial part of their environment, a signal that governs behavior, reproduction, and survival. Some animals are more active during bright, moonlit nights. Others hide, waiting for the darkness of the new moon to venture out. The amount of light available shapes the rhythms of life in ways that are invisible to us, but essential to them. Nocturnal predators, like owls and foxes, benefit from moonlight. It gives them just enough visibility to hunt without exposing them the way daylight would. Their prey, in turn, has to be more cautious on bright nights. Small mammals often stay closer to cover when the moon is full, reducing their foraging time and taking fewer risks. The balance between predator and prey shifts subtly with the phases of the moon, an ancient game of light and shadow played out every month. Some insects time their activity to the moon. Certain moths, for example, use the moon as a navigational reference, keeping it at a constant angle as they fly. This works well when the moon is a distant point of light, but it fails disastrously when they encounter an artificial light source, like a street lamp or a candle. They try to maintain the same angle to the light, but because the light is close, they end up spiraling inward, trapped by their own navigation system. The moon, being far away, never tricks them this way. Sea turtles are among the most famous moon followers. When baby sea turtles hatch on beaches, they instinctively move toward the brightest part of the horizon, which, in natural conditions, is the moonlight reflecting off the ocean. This leads them to the water. But on beaches near human development, artificial lights can confuse them, drawing them inland instead. Conservationists often dim or shield lights during hatching season to give the turtles a better chance of following the real moon. Coral reefs also respond to the moon. Many species of coral spawn only during specific lunar phases, releasing eggs and sperm into the water in coordinated events that happen once or twice a year. The timing is precise, triggered by a combination of moon phase, water temperature, and day length. Scientists aren't entirely sure how corals sense the moon, but it's clear that they do. The light of the full moon penetrates the water and reaches the reef, and somehow the corals read that signal and respond. Fish, too, are influenced by lunar cycles. Some species migrate based on the moon, others change their feeding patterns. The light level at night affects how visible they are to predators, so schooling behavior and vertical migration, moving up or down in the water column, often sync with the lunar cycle. Fishermen have long known that the moon affects fish behavior, and they plan their trips accordingly. Birds use moonlight for migration. Many species migrate at night, and while they navigate primarily by stars and Earth's magnetic field, moonlight helps them see the landscape below. On bright, moonlit nights, more birds take flight. On dark, moonless nights, migration slows. The light doesn't tell them where to go, but it makes the journey safer, allowing them to avoid obstacles and stay oriented. Even plants, which don't have eyes or a nervous system, can respond to moonlight. Some studies suggest that certain plants grow slightly differently depending on the lunar cycle, though the effects are subtle and still debated. The idea of planting by the moon, a practice in traditional agriculture, holds that seeds germinate better when planted during certain lunar phases. Modern science has found mixed evidence for this, but the tradition persists. Whether it works through light, gravity, or simple coincidence, people continue to follow it, guided by a rhythm older than written history. Humans, too, are animals, and we are not immune to the moon's influence. Our sleep patterns can shift with the lunar cycle. Studies have found that people tend to sleep slightly less during the full moon, even when they're in controlled environments with no view of the sky. The effect is small, about 20 minutes on average, but it's measurable. Why this happens is unclear. It may be a leftover from our evolutionary past, when sleeping deeply during bright nights was riskier. Or it may be something more subtle, a sensitivity to gravitational or electromagnetic changes that we don't yet understand. There's also the well-known association between the moon and mood. The word lunacy comes from luna, the Latin word for moon, reflecting an old belief that the full moon could cause madness or erratic behavior. Modern studies have largely debunked the idea that the moon affects mental health in a significant way, but the belief persists. Emergency rooms, police stations, and schools often report anecdotal spikes in unusual behavior during the full moon. Whether this is real or simply a case of confirmation bias, people noticing and remembering the full moon when something strange happens but ignoring it otherwise, is still an open question. What's undeniable is that the moon has psychological weight. It's a presence. When the full moon rises, people notice. They point it out. They take photos. They pause. There's something about it that draws attention, that interrupts the flow of an ordinary evening. Maybe it's the brightness, or the beauty, or the rarity of really looking up. Or maybe it's something deeper, a recognition that we're part of something larger, something that was here long before us and will be here long after. Moonlight has been used for centuries as a natural nightlight, a way to navigate dark spaces without artificial illumination. Before electric lights, people timed travel, work, and social gatherings around the moon. Roads were safer under a full moon. Rivers were easier to cross. Fields could be harvested late into the evening. The moon was practical. It extended human activity beyond the limits of daylight. Even now, in places without electricity, the moon still serves this role. In rural areas, in developing regions, in remote wilderness, the full moon is anticipated and appreciated. It's a few nights each month when the darkness is less absolute, when the path home is visible, when the night feels a little less isolating. There's a particular kind of silence that comes with moonlit nights. It's not the absence of sound exactly, but a quality of stillness that seems to accompany the light. Maybe it's because moonlight is soft and doesn't demand attention the way bright light does. Or maybe it's because the creatures of the night, the insects and birds and mammals that move in darkness, adjust their behavior in response to the light. Whatever the reason, a moonlit night often feels quieter than a dark one, as if the world is holding its breath. Walking outside under a full moon has a meditative quality. The world is visible but simplified. Colors are muted. Details are softened. There's enough light to see where you're going, but not enough to be distracted by every leaf and stone. It encourages a kind of gentle focus, a calm awareness. You're present, but not overstimulated. The light asks nothing of you, it just is. This is one reason why moonlight is so often associated with reflection and introspection. It's light that invites you to slow down, to notice, to think. It doesn't push or demand, it offers. And in that offering, there's a kind of permission to rest, to let go of the urgency of the day and simply exist in the softer, slower rhythm of night. Moonlight is also forgiving. Under its glow, imperfections are hidden. Scars, blemishes, wear and tear, all of it fades into shadow. Buildings look softer, faces look gentler. The harshness of midday sun, which reveals every crack and flaw, is replaced by a diffuse glow that smooths and blurs. The world under moonlight is a kinder version of itself. Maybe that's part of why moonlight feels romantic. It's not just the beauty of the light itself, but the way it transforms what it touches. It makes the familiar feel new. It turns an ordinary street into a scene from a story. It gives even mundane moments a sense of occasion. Standing in moonlight, you're not just standing. You're part of something. A moment, a mood, a fleeting alignment of light and place and feeling. The absence of moonlight, the dark of the new moon, is just as significant as its presence. For a few nights each month, the moon is invisible. It rises and sets with the sun, lost in the glare of daylight, and the nights are as dark as they can be. This is when the stars come fully into view, when the Milky Way is visible, when the sky opens up and reveals its depth. Astronomers and stargazers wait for the new moon. It's the best time to observe faint objects, distant galaxies, nebulae and clusters that will be washed out by moonlight. In a way, the moon's absence is a gift. It reminds us that there's more to the night sky than the moon. That the moon, as bright and beautiful as it is just one object among billions, and when it steps aside, the rest of the universe comes forward. The new moon is also a time of beginnings. Many lunar calendars mark the start of the month with the first sighting of the crescent moon, the thin sliver that appears just after the new moon phase. This crescent has been a symbol across cultures: Islam, Judaism, ancient Mesopotamia, a sign of renewal, of time turning, of cycles beginning again. The dark sky before the crescent is a kind of pause, a blank page, a moment of potential before the light returns. There's a psychological shift that happens during the new moon. Without the moon's light, the night feels deeper, more enveloping. The darkness is more complete. For some people, this feels comforting, like being wrapped in a blanket. For others, it feels unsettling, as if something is missing. The absence is palpable. The sky, which had been softly lit, is now black, and in that blackness, other things become visible. Not just stars, but sounds, sensations, the quiet presence of the world continuing in the dark. The new moon is when nocturnal animals are most active. Predators have the advantage of true darkness. Prey animals are more vulnerable. The balance shifts. Without moonlight to reveal movement, the night becomes a tactile, auditory, olfactory world. Animals rely more on hearing, on scent, on whiskers and vibrations. The absence of light forces a different kind of awareness. For humans, the new moon is a reminder of how much we depend on light. Even a little light, like the glow of a crescent moon, makes a difference. Without it, the world shrinks. We stay closer to home, closer to our own lights. We rely on flashlights, lanterns, fires. We feel the limits of our vision more acutely. The new moon teaches humility. It shows us that we are not naturally creatures of the night. We need help. We need the moon. And then, a day or two after the new moon, the crescent returns. At first, it's barely visible, a faint curve low in the western sky just after sunset. You have to look carefully to see it, and even then, it's easy to miss if the horizon is hazy or cluttered. But if you catch it, that first crescent feels like a reunion. The moon is back, the cycle is continuing, the light is returning slowly, one thin slice at a time. Watching the moon grow from crescent to full is one of the small pleasures of paying attention to the sky. Each night it's a little higher, a little brighter, a little more complete. The progression is gradual but steady. There's no rush. The moon takes its time, filling in, waxing, moving from a sliver to a half to a gibbous to a full round disk. And then, just as slowly, it begins to wane, shrinking back down, emptying, until it disappears again into the new moon, and the cycle starts over. This rhythm of growth and decline, fullness and emptiness, is one of the most fundamental patterns in nature. It's a rhythm we see in tides, in seasons, in our own lives. The moon makes it visible. It gives it a face, a shape, a predictable schedule. And because it's so consistent, so reliable, it becomes a kind of anchor. No matter what else is changing, the moon will go through its phases. It will wax and wane. It will rise and set. It will mark time. There's comfort in that predictability. In a world where so much feels uncertain, the moon is dependable. You can count on it. You can plan around it. You can look forward to the next full moon, knowing it will come, knowing it will light the night in the same way it has for billions of years. The light of the moon is a gentle light. It doesn't demand anything. It doesn't glare or blind or heat. It simply falls, soft and even, across whatever happens to be beneath it. Fields, forests, oceans, cities, deserts, mountains. The moon lights them all with the same impartial glow. It doesn't choose. It doesn't favor. It just is. And that evenness, that neutrality, is part of what makes it so calming. When you stand in moonlight, you're standing in a light that has touched the entire visible face of the earth. The same light that's falling on you is falling on distant coasts, on remote islands, on places you'll never see. It's a shared experience, even if you're alone. The moon connects. It links the solitary walker on a country road with the insomniac in a city apartment, the sailor on a dark sea with the camper in a mountain meadow. All of them, in that moment, are under the same light. Moonlight is also a light that's easy to ignore. It doesn't insist. If you're busy, distracted, indoors, you might not notice it at all. It requires a certain stillness, a certain willingness to pause and look. But when you do, when you step outside and let your eyes adjust, it reveals itself. Not all at once, but gradually, like a whisper that grows louder the more you listen. And once you see it, really see it, it's hard to unsee. You start noticing the moon more often. You start tracking its phases. You start recognizing the quality of moonlight, the way it changes the texture of the night. You become attuned to it, aware of its presence or absence. It becomes part of your awareness, a quiet companion in the background of your life. Tonight, wherever you are, the moon is somewhere in its cycle. It might be full, flooding your room with silver. It might be new, invisible, leaving the sky to the stars. It might be waxing or waning, a half-light, a crescent, a gibbous curve. Whatever phase it's in, it's there, turning, reflecting, marking time. And the light it sends, the soft, borrowed glow that reaches across the dark, is the same light that has guided travelers, inspired poets, and accompanied countless quiet moments for as long as there have been eyes to see it. There's nothing you need to do with this knowledge. No quiz, no task, no requirement. Just the gentle awareness that moonlight exists, that it has always existed, and that it will continue night after night, phase after phase, long after this moment has passed. It's a constancy, a rhythm, a quiet presence in the turning of the world. And as you rest, as your breathing slows and your thoughts drift, that presence remains. Soft, patient, steady, always there, even when you're not looking. Always turning, always reflecting, always lighting the edge of the night. The moon has no light of its own, and yet it has been a source of illumination for longer than we can measure. Before fire, before tools, before language, the moon was there, casting its pale glow across the landscape. Early humans looked up at it, tracked its movements, felt its light on their skin. They had no words for what it was, no understanding of reflection, or orbit, or gravity. But they knew it was important. They knew it changed. They knew it returned. The regularity of the moon's cycle may have been one of the first patterns humans recognized. Day and night alternate, but irregularly depending on the season. The stars wheel overhead, but their movements are slow and complex. The moon, though, has a clear rhythm. New moon, crescent, half, gibbous, full, and back again. 29.5 days, over and over. It's a pattern simple enough to notice, consistent enough to remember, and useful enough to rely on. Some anthropologists believe that the lunar cycle may have been one of the earliest forms of timekeeping. Notches carved into ancient bones, some over 20,000 years old, seem to track the phases of the moon. If this interpretation is correct, it means that humans have been paying attention to moonlight for tens of millennia, watching it wax and wane, marking its passage, using it to organize their lives. The moon was the first calendar. There's something profound in that. The moon didn't just light the night, it structured time itself. It gave early humans a way to think about the future, to plan, to anticipate. When the moon is full again, we will do this. When the moon is dark, we will do that. The phases became a framework, a scaffold on which to hang memory and intention. The moon made time visible. Even now, in a world filled with clocks and calendars, the moon still marks time in its own way. Months are based on it. The word month derives from moon. Many traditional festivals and holidays are timed to lunar phases. Religious observances, agricultural practices, fishing seasons. So many rhythms of human life are still at some level synchronized with the moon. We may not think about it consciously, but the moon is woven into the fabric of how we organize our existence. Moonlight changes not just in brightness, but in duration. In the days leading up to the full moon, the moon rises earlier and earlier, until on the night of the full moon itself it rises just as the sun sets. The two luminaries trade places on opposite horizons, one sinking as the other climbs. This is why the full moon is visible all night long. It rises at dusk and sets at dawn, tracing a path across the sky that mirrors the sun's daytime journey. After the full moon, the pattern reverses. The moon rises later each night, appearing first in the late evening, then near midnight, then in the small hours before dawn. By the time it's a waning crescent, it rises only an hour or two before the sun, visible briefly in the pale light of early morning before fading into the brightness of day. And then it vanishes into the new moon, and the cycle begins again. This shifting schedule means that the character of moonlit nights changes throughout the month. A waxing moon lights the evening, the early part of the night when people are still awake, still moving. A waning moon lights the deep night and the hours before dawn, the time of sleep and stillness and solitude. The same moon, the same light, but encountered at different times in different states of wakefulness feels different. There's a particular magic to seeing the waning crescent moon in the hour before sunrise. The world is still dark, but there's a sense of anticipation, a faint brightening on the eastern horizon that suggests the sun is coming. And there, hanging low in the sky, is the thin crescent, pale and delicate, almost transparent. It feels fragile, as if it might dissolve at any moment. And in a sense, it does. As the sky brightens, the crescent fades, becomes harder to see, and finally disappears, swallowed by the light of day. That moment of disappearance, when the moon is still there but no longer visible, is a reminder of how much depends on contrast. The moon doesn't stop reflecting light when the sun rises. The same amount of light is bouncing off its surface, but against the brightness of the daytime sky, it becomes invisible. Our eyes can't pick it out. It's there, but we can't see it. The light is real, but our perception of it is conditional. This is true of so much in life. Presence and visibility are not the same thing. Something can exist and still be unseen. The moon during the day is one example, stars at noon are another. They're shining just as brightly as they do at night, but the light of the sun overwhelms them. They're hidden not by their absence, but by the presence of something brighter. Moonlight, in a way, teaches us about context. It teaches us that the same thing can appear entirely different depending on what surrounds it. A dim light in darkness is a beacon. The same light in brightness is invisible. The moon's light doesn't change, but our ability to perceive it does, moment by moment, phase by phase, depending on where we are, what time it is, and what else is competing for our attention. The surface of the moon, as distant and untouchable as it seems, has been marked by human presence. 12 people have walked on it. They left footprints, flags, equipment, and those footprints, because there's no wind or rain to erase them, will remain for millions of years. The moon carries the imprint of our brief visits, frozen in time, a record of the moment when humans left Earth and touched another world. But despite those visits, the moon remains remote. We've seen it up close, studied its rocks, mapped its surface, but we haven't changed its essential nature. It's still the same moon that early humans looked up at. It still reflects the same light. It still follows the same orbit. Our presence there was a moment, a flicker, in the moon's long existence. The footprints will fade eventually, worn away by micrometeorites and the slow erosion of space. And the moon will continue, orbiting, reflecting, lighting the night as it always has. There's something humbling in that. We reached the moon, one of humanity's greatest achievements, and yet the moon itself was unimpressed. It didn't change, it didn't notice. It just continued being what it's always been, a cold, airless rock reflecting sunlight. Our triumph was enormous for us, but to the moon, we were just a brief interruption in the long silence. Moonlight has inspired more poetry than perhaps any other natural phenomenon. Thousands of poems in hundreds of languages, across centuries and continents, have tried to capture its essence. The moon is a symbol of longing, of distance, of beauty, of change. The moon is a companion to the lonely, a witness to secret meetings, a metaphor for the passage of time. The moon is inconstant, always changing, never the same. The moon is faithful, always returning, reliable in its cycles. Poets have called it cold, called it silver, called it a lantern, a mirror, a pearl, a ghost. They've compared it to a face, a boat, a sickle, a door opening in the sky. They've used it to talk about love, about loss, about memory, about the distance between what we want and what we have. The moon, in poetry, is rarely just the moon. It's always standing in for something else, some feeling or idea that's hard to express directly. And yet, for all the metaphors, there's something about the actual experience of moonlight that resists language. You can describe its color, its brightness, its effect on the landscape. You can talk about how it makes you feel. But the thing itself, the actual quality of standing in moonlight, remains somehow beyond words. It has to be experienced. It has to be felt. No description, however beautiful, quite captures it. Maybe that's why poets keep trying. Because moonlight is one of those things that exists in the gap between experience and language. It's real, physical, measurable, and yet it evokes something that numbers and descriptions can't quite reach. It's light, but it's also mood, atmosphere, feeling. It's a thing and a symbol at the same time. And that duality, that slipperiness, makes it endlessly fascinating. Moonlight has also been a subject of scientific study, not just for what it tells us about the moon, but for what it reveals about perception, ecology, and the history of Earth. By studying how moonlight behaves, how it's reflected and absorbed, how it varies with angle and distance, scientists learn about the moon's composition, its age, its history. The light carries information encoded in wavelengths and intensity and timing. But moonlight also tells us about ourselves, about how human vision works, how our eyes adapt to different levels of light, how our brains construct images from limited information, about how other species have evolved to use or avoid moonlight, shaping ecosystems and behaviors in ways we're only beginning to map, about how light and dark, presence and absence structure the living world. In a sense, moonlight is a bridge between Earth and Moon, between sun and night, between seeing and not seeing. It's light that has traveled from one world to another, been transformed and arrived here carrying traces of both. It's neither fully bright nor fully dark. It occupies a middle space, a threshold, and in that threshold many things become possible that aren't possible in full light or full darkness. There are nights when the moon appears larger than usual, swollen and heavy on the horizon. This is called the moon illusion, and it's one of the most persistent tricks of perception in all of nature. The moon doesn't actually change size. It's the same distance away, the same physical diameter, whether it's rising on the horizon or high overhead. But when it's near the horizon, especially when there are trees or buildings or mountains to compare it to, it looks enormous. When it's overhead, isolated in empty sky, it looks smaller. Scientists have studied this illusion for centuries and still don't fully agree on what causes it. Part of it may be the way our brains process distance and scale. When the moon is on the horizon, we see it in the context of distant objects, and our brain interprets it as being far away. But it's also large in our field of vision, so our brain compensates by perceiving it as bigger. When it's overhead, there's no context, no comparison, and it looks smaller even though it takes up the same amount of space in our vision. Another theory involves the shape of the sky. We don't perceive the sky as a perfect dome. We perceive it as flattened, like an upside-down bowl that's wider than it is tall. This means we unconsciously think of the horizon as farther away than the zenith. If the moon looks the same size at both locations, our brain assumes the one at the horizon must be larger because it's farther away and yet appears the same. It's a kind of optical correction that backfires, creating an illusion instead of clarity. Whatever the cause, the moon illusion is a reminder that perception is not passive. We don't just receive light and see what's there. Our brains actively construct what we see, interpreting, adjusting, filling in gaps. Most of the time this works well. It helps us navigate the world, understand distances, recognize objects. But sometimes, as with the moon illusion, it leads us astray. We see something that isn't quite real, a moon enlarged by expectation and context rather than physics. There's something poetic in that. The moon on the horizon, huge and golden, feels more significant, more magical than the same moon high overhead. And in a way, it is more significant because we experience it as larger. The physical moon may be the same size, but the phenomenological moon, the moon as experienced, is genuinely different. Our perception is part of reality. What we see is what we get, even when what we see is shaped by the architecture of our own minds. The color of the moon changes with atmospheric conditions. A moon rising through humid summer air might look pale and washed out, its light scattered by moisture. A moon rising through cold, dry winter air might look sharp and white, its light traveling unimpeded. A moon rising through smoke from wildfires might look red or orange, the light filtered through particles suspended in the atmosphere. Each of these moons is the same moon, but each carries the signature of the air it passed through. There are rare moments when the moon takes on unusual colors. During a lunar eclipse, when Earth's shadow falls across the moon can turn deep red or copper-colored. This happens because sunlight is refracted through Earth's atmosphere and bent toward the moon. The atmosphere filters out the blue light and lets the red light through, casting a ruddy glow on the lunar surface. It's the light of every sunrise and sunset on Earth all at once, projected onto the moon. These eclipses have frightened and fascinated humans for millennia. In many cultures, a lunar eclipse was seen as a bad omen, a sign that the moon was being devoured or attacked. People would bang drums, shout, make noise, trying to scare away whatever was consuming the moon. They didn't know about shadows or refraction, but they knew the moon was changing in a way it wasn't supposed to, and that felt dangerous. Now we understand what causes lunar eclipses and we know they're harmless. But there's still something unsettling about watching the moon darken and redden. It's a disruption of the normal order. The moon, which is supposed to be bright and constant, becomes dim and strange. Even knowing the science, even expecting it, the sight of a blood-red moon hanging in the sky carries a weight, a sense of wrongness that's hard to shake. Lunar eclipses can only happen during a full moon, when Earth is directly between the sun and the moon. But they don't happen every full moon because the moon's orbit is tilted relative to Earth's orbit around the sun. Most of the time, the moon passes above or below Earth's shadow. Only occasionally do the alignments line up just right, and Earth's shadow sweeps across the moon's face. These moments are predictable, calculable, and yet they still feel like events, like something worth staying up for, worth stepping outside to witness. The moon's gravity pulls on Earth, and Earth's gravity pulls on the moon. This mutual attraction creates tides, not just in the oceans, but in the solid body of the Earth itself. The ground beneath your feet rises and falls by several centimeters each day as the moon passes overhead. You don't feel it because everything around you is rising and falling too, but it's happening. The moon is bending the planet, stretching and compressing it in a slow rhythmic pulse. In the oceans, this effect is more visible. Water is fluid and responds more readily to gravitational pull. As the moon orbits Earth, it creates a bulge of water on the side of Earth facing it, and another bulge on the opposite side. These bulges move around the planet as the Earth rotates, creating the rise and fall we call tides. High tide occurs when you're in one of the bulges. Low tide occurs when you're between them. The sun also contributes to tides, though less so than the moon because it's much farther away. When the sun and moon align during a new moon or full moon, their gravitational pulls combine, creating especially high and low tides called spring tides. When the sun and moon are at right angles during the quarter moons, their pulls partially cancel out, creating more moderate tides called neap tides. The dance of sun, moon, and earth creates a complex pattern of water movement that varies day by day, month by month. Tides shape coastlines, create habitats, influence weather patterns. They carry nutrients, move sediment, create currents. Many marine organisms time their breeding and feeding to the tides. Intertidal zones, the areas between high and low tide, are among the most productive ecosystems on Earth, constantly washed and refreshed by the rhythmic movement of water. All of this happens because the moon is pulling on the ocean, and the ocean is responding. People who live near the coast often develop an intimate awareness of tides. They know when the water will be high or low. They plan their activities around it. Fishermen know which tides bring which fish. Beachcombers know when to look for shells and driftwood. Sailors know when they can enter or leave harbour. The tide becomes part of the rhythm of daily life, as regular and important as sunrise and sunset. And underlying all of it is the moon, its gravity, its position, its phase. The same light that illuminates the night also pulls the oceans back and forth twice a day, every day, in a pattern that has continued for billions of years. Moonlight and tides are connected, two effects of the same celestial relationship. When you stand on a beach under a full moon, watching the waves surge up the sand, you're witnessing both at once. Light and gravity, two aspects of the moon's presence, shaping the world around you. There are places on Earth where moonlight takes on a surreal quality, where the landscape and the light combine to create something otherworldly. Deserts under a full moon become silvered expanses, dunes etched with sharp shadows, the horizon blurred into darkness. Snow-covered fields under moonlight glow with a pale luminescence, as if lit from within. Forests under the moon become layered, textured, every tree trunk a pillar of shadow, every gap between branches a window to scattered light. Water under moonlight is perhaps the most magical. The moon's reflection stretches across the surface in a shimmering path, a road of light that seems to lead directly to you. This phenomenon, called a moon path or moon road, has inspired countless stories and images. It looks like you could walk on it, follow it across the water to some distant shore. Of course you can't. The path is made of reflected light and it moves as you move, always centered on your perspective. Every person standing on the shore sees their own moon path, unique and unrepeatable. The moon path exists because water is not perfectly smooth. Small waves and ripples catch the moonlight and reflect it in slightly different directions, creating a scattering of bright spots that blend together into a luminous streak. On a perfectly calm surface, you would see only a single point of reflection, sharp and small, but water is almost never perfectly calm. There's always some motion, some texture, and that texture turns the reflection into a path. Lakes, rivers, and oceans all create moon paths, but each looks different. A lake, sheltered and relatively still, produces a narrow, well-defined path. The ocean, with its constant swell, creates a broader, more diffuse glow. A river, flowing and rippling, breaks the reflection into fragments and dances. The same moon, the same light, but the character of the water shapes how we see it. Standing beside water at night and watching the moon's reflection is a quietly meditative experience. The light is always moving, always shifting, responding to the smallest disturbance. A breeze ruffles the surface, and the reflection trembles. A boat passes, and the wake shatters the light into 1,000 pieces, then slowly reassembles it. The moon itself is steady, but its reflection is alive, constantly remaking itself. There's a parallel there to perception itself. The moon is fixed, objective, external, but what we see of it, what we experience, is filtered through so many layers. Atmosphere, water, our own eyes and brains. The moon we perceive is not quite the moon that exists. It's a reflection, a translation, a version shaped by the medium through which it passes. And that version is always changing, always in motion, never quite the same twice. Moonlight has been used in navigation for as long as humans have traveled at night. Sailors used the moon to gauge time and tide. Travelers used it to light their paths. In some cultures, people would wait for the moon to rise before beginning a journey, knowing that its light would make travel safer. The full moon, in particular, was a time for movement, for action, for venturing out into the world with the confidence that you could see where you were going. Before compasses and GPS, before maps and roads, the sky itself was the primary navigational tool. The stars told direction, the sun told time, and the moon told the phase of the month, the state of the tides, and provided light to travel by. These three sources of celestial information, sun, moon, and stars, were woven together into a system of knowledge that allowed humans to cross oceans, traverse deserts, and find their way through unmarked wilderness. The moon, because it's so bright and so obvious, was perhaps the easiest of the three to use. You didn't need special knowledge to benefit from moonlight. You just needed to look up, see where the moon was, and adjust your plans accordingly. If the moon was full, you could travel at night. If it was new, you waited for daylight or stayed home. Simple, direct, practical. Even now, in a world filled with artificial light and electronic devices, moonlight remains useful. Hikers and campers appreciate a full moon because it means they can move around camp without a flashlight. Photographers chase the full moon for the soft, even light it provides. Astronomers avoid it for the same reason, seeking out the dark skies of the new moon. The moon still shapes what we do, and when we do it, more than we might realize. There's also something primal in the way moonlight affects our sense of time. Under moonlight, time feels slower, more elastic. The urgency of daylight fades. There's less pressure to accomplish, to produce, to move forward. The night, especially a moonlit night, invites a different pace. A wandering, reflective, unhurried pace. You don't rush through moonlight, you linger in it. This may be why moonlit walks feel so different from daytime walks. You're covering the same ground, seeing the same landmarks, but the experience is entirely different. Everything is quieter, slower, more contemplative. The world under moonlight feels like a parallel version of itself, recognizable but transformed, familiar but strange. And in that strangeness, there's space to think, to feel, to notice things you might overlook in the brightness of day. Some animals avoid moonlight. For prey species, the full moon is dangerous. Predators can see better, and being visible means being vulnerable. Small mammals, many rodents, and some insects reduce their activity during bright nights, staying hidden, waiting for the safety of darkness. This behavior is so widespread that ecologists have documented what they call lunar phobia in certain species. The moon, for them, is not a gentle light but a threat. This creates an interesting dynamic in ecosystems. When the moon is full, predators have an advantage, but prey is scarce. When the moon is new, prey is more active, but predators have a harder time hunting. The balance of life shifts with the lunar cycle, an oscillation of risk and reward that plays out every month. The amount of light in the night sky directly affects who eats and who gets eaten, who thrives and who struggles. Humans, being neither pure predator nor pure prey in the modern world, have a more neutral relationship with moonlight. We appreciate it for its beauty, its utility, its associations. But we don't depend on it for survival the way our ancestors might have. We've insulated ourselves from the night, from darkness, from the cycles of the moon. We can create our own light whenever we want, and we do. The night is no longer a barrier, but in doing so, we've lost something. We've lost the intimate knowledge of the moon's phases, the awareness of when it rises and sets, the sense of being part of a larger rhythm. Most people now couldn't tell you what phase the moon is in without looking it up. We've turned the moon into an occasional decoration, something to glance at and admire, rather than something to live by. The light is still there, still falling, but we've stopped paying attention. There are times when moonlight feels almost tangible, like something you could reach out and touch. On very cold nights, when the air is clear and still, moonlight seems to have weight, to press gently against surfaces, to pool in corners and hollows. This is partly an effect of how the cold air sharpens contrasts, making shadows deeper and highlights brighter. But it's also something about the quality of winter moonlight itself, which feels harder, more crystalline, less forgiving than the soft glow of summer. In winter, the moon rises higher in the sky and stays up longer. The geometry of Earth's tilt means that when the sun is low in winter, the full moon is high, tracing a path across the sky that mirrors the summer sun. This gives winter moonlight a different character. It's more direct, less filtered, and it falls on a world that's often covered in snow, which reflects it back, amplifying its brightness. A winter landscape under a full moon can be almost blindingly bright, the snow glowing, the shadows stark and blue. Walking through snow under moonlight is a study in contrasts. The snow itself is luminous, reflecting the moon's glow and turning the ground into a pale, shimmering surface. But the shadows cast by trees and rocks and fences are deep, almost black, creating a stark division between light and dark. There's no middle ground, no gradual transition. Everything is either lit or not lit, and the boundary between the two is sharp. This harsh beauty has its own appeal. It's honest, direct. There's no ambiguity, no softness to hide behind. The world under winter moonlight is revealed in its simplest form, shape, shadow, space. It's a world stripped down to essentials, and there's a kind of clarity in that. A cold clarity, perhaps, but clarity nonetheless. In warmer months, moonlight is gentler. The air is softer, often humid, and the light diffuses through it, creating halos and glows. Summer moonlight filters through leaves, dappling the ground, creating patterns of light and shadow that shift with the breeze. It's less about contrast and more about gradation. about subtle transitions from light to dark and back again. The world under summer moonlight is layered, textured, complex. The temperature of the air affects more than just how the light looks. It affects how it feels to be in it. Moonlight on a warm night invites you outside. It feels like an extension of the day, a continuation of warmth and comfort. You can sit outside, linger, let the night unfold around you without discomfort. The moonlight becomes part of a larger sensory experience. The warmth of the air, the sound of crickets, the smell of grass or flowers, the feel of a breeze on your skin. Moonlight on a cold night is different. It's beautiful, but from a distance. You admire it through a window, or you bundle up and venture out briefly, aware of the cold, aware that you can't stay long. The moonlight is still there, still falling, but the experience is shaped by the need to stay warm, to keep moving, to return to shelter. It's a more solitary, more internal experience. Less about being immersed in the night, and more about witnessing it from a respectful distance. Seasons change the length of moonlit nights. In summer, nights are short, and even a full moon is only visible for a limited time. In winter, nights are long, and the moon can be up for 12 hours or more, arcing high across the sky, presiding over the darkness. This seasonal variation adds another layer to the rhythm of moonlight. It's not just the phases of the moon that change, but the duration and intensity of its presence. People in polar regions experience moonlight in an entirely different way. During the long polar night, when the sun doesn't rise for months, the moon becomes especially important. It's one of the few sources of natural light, and during the full moon it can provide enough illumination to move around, to work, to live. The full moon in the Arctic or Antarctic is not just bright, it's essential. It breaks the monotony of darkness, offers a rhythm, a marker of time when days and nights blur together into one continuous dark period. In these extreme environments, the moon's phases take on almost spiritual significance. The return of the full moon after weeks of darkness is celebrated, welcomed, a reassurance that light still exists, that the cycle continues. And when the moon wanes and disappears, leaving only starlight and aurora, the darkness deepens, and people retreat further inward, waiting for its return. Moonlight near the poles also behaves strangely. The moon can stay above the horizon for days at a time, circling without setting, or it can disappear below the horizon for weeks. The geometry of high latitudes distorts the familiar patterns, creating experiences of moonlight that people from temperate regions would find alien. The moon becomes not a nightly visitor, but a slow presence or absence that dominates entire weeks. There's a phenomenon called moon blindness that used to be documented in sailors and travelers who spent long periods under bright moonlight, especially in reflective environments like snow or water. Their eyes, adapted to low light for extended periods, would become strained, sometimes developing temporary vision problems. The moon, which seems so gentle compared to the sun, can still be too much if you're exposed to it continuously in a highly reflective environment. Even reflected light has its limits. This is a reminder that moonlight, for all its softness, is still light. It's still energy. It's still photons carrying momentum and information. It can affect photographic film, cause chemical reactions in certain materials, even contribute to the weathering of surfaces over long periods. It's easy to think of moonlight as passive, as merely decorative, but it's active. It does things. It changes things, just slowly, subtly, over time. The moon's phases were once the basis for agriculture. Planting calendars, still used in some traditional farming communities, recommend planting certain crops during specific moon phases. Root vegetables during the waning moon, leafy greens during the waxing moon. The theory is that the moon's gravitational pull, the same force that creates tides in the ocean, also affects the water in soil and plants, and that timing your planting to these cycles improves growth. Modern agricultural science is skeptical of this. Studies have found little to no consistent effect of moon phases on plant growth. But the practice persists, passed down through generations rooted in centuries of observation and tradition. Whether it works because of the moon or because careful timing and attention improve outcomes, regardless of the reason, the result is the same. People continue to plant by the moon, to watch its phases, to align their work with its rhythm. There's something appealing in that, regardless of whether the science supports it. The idea of being in sync with natural cycles, of working with the rhythms of the sky rather than against them, resonates. It's a way of feeling connected to something larger, something ancient. And maybe that connection, that sense of participating in a pattern that has repeated for millennia, is valuable in itself, independent of any measurable effect on crop yields. Moonlight fades so gradually you barely notice it leaving. As dawn approaches, the sky begins to brighten, imperceptibly at first. The stars dim one by one. The moon, if it's still visible, becomes paler, more translucent, losing its luminosity against the growing light. And then, without any clear moment of transition, it's day. The moon is gone, swallowed by the brightness, and the world has changed modes entirely. This slow fade is the opposite of sunset, which often feels dramatic, colorful, full of change. Dawn is quieter, more subtle. The light doesn't announce itself. It seeps in, fills the sky gradually, and only in retrospect do you realize that night has ended. The moon's departure is similarly understated. It doesn't make a show of leaving. It simply becomes invisible, receding into the background while the sun takes center stage. There's a kind of grace in that. The moon doesn't compete. It doesn't try to hold onto the sky when its time is over. It yields, steps back, lets the day begin. And in a few hours, or a few days depending on its phase, it will return, not demanding attention, just quietly present, offering its light to anyone who happens to look up. If you watch the moon over a full month, tracking it night after night, you'll see a complete cycle of transformation. New to crescent, to half, to gibbous, to full, and then back again. Each phase is distinct, but the transitions are so smooth, so gradual, that you might miss them if you're not paying attention. One night the moon is a crescent, 2 nights later it's noticeably fuller, a week later it's half, then gibbous, swelling toward fullness, then full, round and bright, and then it begins to empty, to wane, passing back through the same phases in reverse. This rhythm is one of the most reliable patterns in nature, more reliable than weather, more reliable than seasons which shift and vary. The moon's phases are mathematically precise, predictable, centuries in advance. You can know, right now, what phase the moon will be in on this date 10 years from now, 100 years from now. That level of certainty is rare, it's comforting. And yet, each cycle feels new. Each full moon, even though you've seen hundreds of full moons, still has the power to catch your attention. The moon never becomes boring. It never becomes routine. Part of this is because we don't watch it every night. We dip in and out of awareness, catching glimpses, noticing it sometimes, and forgetting it others. And part of it is because the moon, despite its predictability, is always appearing in different contexts, different weather, different seasons, different moments of your life. The moon is the same, but everything around it, including you, is changing. There's a tradition in many cultures of making wishes on the new moon, or of acknowledging the full moon with some small ritual or observance. These practices vary widely, but they share a common thread. They use the moon as a marker, a reminder to pause, to reflect, to notice the passage of time. The moon becomes not just light in the sky, but a prompt, a chance to step back from the rush of daily life and consider where you are, what you're doing, what you hope for. You don't have to believe in the power of wishes or the influence of lunar phases to find value in this. The simple act of pausing, of looking up, of taking a moment to acknowledge the moon's presence is itself worthwhile. It's a form of attention, a small ritual of noticing. And noticing, paying attention, being present, these are things that don't come naturally in a distracted world. They have to be practiced. The moon, with its regular cycles, offers a built-in opportunity for that practice. Moonlight will continue long after we're gone. The moon will keep orbiting, the sun will keep shining, the light will keep reflecting, traveling across space, falling on whatever happens to be below. Whether anyone is there to see it or not, the moon will wax and wane, rise and set, light the night in the same patient, unhurried way it has for billions of years. There's something both humbling and comforting in that thought. We are not necessary to moonlight. It existed before us. It will exist after us. But while we're here, we get to experience it. We get to stand in it, walk through it, watch it transform the familiar world into something strange and beautiful. We get to notice the phases, track the cycles, tell stories about what we see. We get to be part of the long history of beings who have looked up at the moon and wondered. Tonight, the moon is somewhere in its cycle. It might be visible from where you are, or it might be hidden. It might be full and bright, or new and dark, or somewhere in between. Whatever phase it's in, it's marking time. It's reflecting light. It's pulling on the oceans, bending the earth, affecting tides and ecosystems and the behavior of countless creatures. It's doing all of this quietly, without fanfare, just as it always has. And somewhere, someone is standing outside, looking up at it. Maybe they're thinking about the science of it, about orbits and reflection and the speed of light. Maybe they're thinking about beauty, about poetry, about what the moon means to them. Maybe they're not thinking at all, just standing there, letting the light fall on them, breathing slowly, feeling the night settle around their shoulders like a familiar weight. The moon doesn't ask anything of you. It doesn't require understanding or appreciation. It simply is. And the light it casts, the soft, borrowed glow that reaches across space and touches your skin, your eyes, the ground beneath your feet, that light is a gift. Not given intentionally, not earned or deserved, just there, always there, turning with the days, waxing and waning, rising and setting, marking time in the oldest language we know. As you rest now, as your thoughts slow and your breathing deepens, that light continues, even if you can't see it, even if clouds cover the sky or walls block the view. The moon is still there, still turning, still reflecting, still casting its pale glow across forests and cities and oceans and deserts and everything in between. The night is full of this light, this quiet presence, this ancient rhythm that connects this moment to every moment that came before and every moment that will come after. You are part of that continuum. You are standing in the same light that illuminated the paths of your ancestors, that will light the way for your descendants. The atoms in your body have passed through stars. The water in your cells has cycled through oceans and clouds and rain for billions of years. And the light falling on you now has traveled from the sun to the moon to here, carrying with it the patient constancy of celestial motion. There is nothing you need to do with this, no task to complete, no lesson to remember, just the gentle awareness that you are here, now, under the same sky that has turned above this planet since long before anything lived upon it. The moon will rise again tomorrow, or the next night, or the night after. It will wax or wane. It will light another night, and another, and another. Steady, patient, unchanging in its change. Rest now. Let your mind drift like moonlight across water, soft and scattered and peaceful. Let the rhythm of your breath match the slow turning of the world beneath you. Let the weight of thought dissolve into the quiet dark. The moon is there, the light is falling, and you are held in the long, slow pulse of night, safe and still, as the hours pass and the sky turns and the earth spins beneath you, carrying you forward through time, through space, through this one brief, luminous moment of being awake under the stars.